Third graders, welcome, welcome. We're going to have another great lesson on forces today. It's Mr. Dubroy speaking, of course. Third graders, today is an exciting day. First off, because we get to read the new book, but also it's an exciting day because I am trying Loom for the first time, which is an extension on Chrome, which is our web browser and how we surf the internet. And so what Loom does is it allows me, and I'm looking down in the bottom left corner of my screen right now, it allows me to be on the screen reading the book to you. Now, I have never used this before, but we know it's really, really important that we try new things. And this may be a really great tool to help us with distance learning, or it may not. Maybe people don't like it. Maybe it's a distraction. We don't really know yet as teachers, so we're trying this out. So I'm definitely going to ask my class for feedback on whether they think that me reading the book in the bottom left corner is good and it helps them understand it, or whether they don't like it. And if you see me in the hallway and you want to give me some feedback, I'd love that. All right. So third graders, we are going to get started today. This book called Give It a Push, Give It a Pull, A Look at Forces is about forces. We have been studying forces now for a couple weeks in science, and we're going to continue to extend our learning. We're going to continue to learn more about forces today. All right. Now, this book is available on Epic. So if you want to search this book on Epic yourself, Give It a Push, Give It a Pull, A Look at Forces, you can do that. And you may want to at the end, because I am going to ask you to do some things. So as I am reading this book today, your job is to think of some things that you have learned. Well, first of all, your job is to listen. But as you are listening, I want you to focus on things you are learning. I also want you to focus on things that you're wondering. Okay? Because I'm going to ask you, as we are reading, to stop and perhaps jot some of those things down in the middle of the book. So third graders, right now, if you do not have a pen or paper or pencil and paper, if you do not have that next to you, pause the video, go get some, and then come back. Because I am going to ask you to try to stop and jot some observations, some comments, some wonderings as we're reading through this book today. All right? So if you have pen and paper and you're ready to go, let's get started. And so first thing I'm going to do, I'm looking at this book. I'm looking at Give It a Push, Give It a Pull, A Look at Forces. And I have to think to myself, because before we start reading books, it's really important that we think about the genre of the book. That helps us understand. We understand what we're reading. And the genre of the book, first thing we have to think about is this book fiction or is it nonfiction? So if it's a fiction book, we're thinking, are there going to be characters in it? Is there a setting? Is there a problem and a solution? Or is it a nonfiction book? And is it just going to be giving us a lot of information? Are there going to be real pictures? Are there a lot of text features in the book? And when I look at this book on the page that you're looking at right now, I'm pretty sure it's a nonfiction book. And the reason, and I hope you can see my arrow here, I think you can, is we have a table of contents with pushes and pulls, putting things in motion, direction and speed, friction, and changing shape. I know those are real things, third graders. I know force is real because we've already been learning about it. When I look at the cover of the book, I know that I see real pictures. That can sometimes be a clue that it's a nonfiction book. And finally, down here, I look at these different text features: index, further reading, glossary. Those text features go along with nonfiction books. So this is a real book about real things. I'm not expecting any characters or problems or solutions, and this looks to be a nonfiction book. So we're going to get started on the next page, and we'll go ahead and we'll start reading. Right away, third graders, I see my heading. Okay, it jumps out at me. It's bigger than everything else on that page, and I'm going to start reading it. Pushes and pulls. A force is a push or a pull. Forces are always with you. They are all around you. We have a caption down here on the bottom. It says, if you've seen someone pushing a swing, then you've seen forces at work. Most of the time, you can see the cause of a force. A person pushes a swing, a truck pulls a boat. When a truck pulls a boat, you see the truck doing the pulling. So I'm reading the caption there, and notice that the line here, it's almost like an arrow kind of, is pointing directly at the truck because the caption is talking about the truck. Sometimes the cause of a force is invisible. Wind pushes leaves across a sidewalk. The wind is invisible. Gravity pulls a paper airplane down. Magnetism holds magnets against a fridge. We have the caption here again. Magnetism pulls this magnet against the fridge. Magnetism is invisible. So that must mean that magnetism is also a force. Interesting. Putting things in motion. Forces put things in motion. Pushing the pedal makes the tires spin. Pulling a wagon makes it roll. Third graders, we know that force is putting things in motion. Motion must mean moving forward or moving backwards or just moving in general, right? Because it's talking pushing the pedal makes the tire spin, pulling the wagon makes it roll. Both of those things are going to make the bike either move or make the wagon move. That's hard to say. Make the wagon move. And so those are examples of motion, and force helps motion. Pushing and pulling your pencil lets you write your name. Thanks to forces, you can write on a sheet of paper. A push moves something away from the force. And we have a caption. This toy car moves away from the boy when he pushes it. A pull moves something closer to the force. Caption down here. The rope moves closer to the girl when she pulls it. Stronger forces can make things move farther. You can throw a ball across a yard with a strong push. A strong force will make a football sail far away from you. A gentle force makes little things move only a little. A little push gets this boat on its way. Caption down here. A gentle force will make a toy boat move a short distance from you. An object's weight can change the force needed to move it. It takes a lot of force to pick up a heavy suitcase. It takes only a little force to lift a light feather. Third graders, I want you at this point to pause this video, and I want you to go ahead and write down a wonder, a question, something you have learned in the first 14 minutes, during the first 14 pages of this book, okay? So go ahead, pause this. When you have written that down, you can unpause it and keep going. Okay, third graders, so I hope that you have paused that. Third graders, one thing I am wondering a little bit, and maybe you were wondering the same thing, and it's kind of a question and a wonder at the same time, right? Is how do you measure? Can you measure force? Right here on page 14, it says, it takes a lot of force to pick up a heavy suitcase, and it takes only a little force to lift a light feather. How can we measure that? I mean, I know when I pick up a heavy suitcase, it's hard, and when I have to pick up like a feather, I don't even feel picking up a feather. But I wonder if there's actually a way to measure that. I don't know. That's one of my wonderings, third graders, and hopefully you were able to write down one of yours. We're going to start again. We have a new heading here, direction and speed. So third graders, as I'm reading this, I know that headings, typically they tell us what we're going to learn about in that chapter. And so I think for this, we're going to learn about now direction and speed, because that's what the heading says. A force makes something move in one direction. Another force can change it. A pitcher throws a ball to the batter. The batter hits the ball. The ball flies in a different direction. Forces change the speed of things. A strong force can make something move quickly. We have our caption here pointing to that gentleman pushing the bobsled. A strong push of a bobsled makes the sled move very quickly. A strong wind makes a sailboat race across the lake. A hard pull on the wheels makes a wheelchair speed along the ground. This racer pulls hard on the wheels of his special wheelchair so he can win the race. Forces make things stop moving. A brick wall will stop a ball. The wall has a lot of force. It pushes against the ball. A tennis ball will stop moving forward when it hits a brick wall. Third graders, I don't know about you, but this line is really interesting to me. It says the wall has a lot of force. It pushes against the ball. That's really interesting. I've never thought of a wall having a lot of force. I mean, the wall's not moving, it just stays there. I wonder what they mean by that. If you have a wonder about that too, third graders, pause this, go ahead and write that down, and then resume when you're done. All right, perhaps you've written that down, third graders, and wonder just like I did. A glass window may not stop a ball. Glass pushes against the ball too, but the ball pushes even harder than the glass. Now that's interesting. A glass ball has less force than a brick wall, so a ball may sail right through it. That's bad news for whoever hit the ball, and that's true. I don't know if you ever broke a window with a ball, but that can be bad news. Third graders, that's really interesting. So the ball is coming, it's going to hit the wall. The wall is here, it stops it, right? But the ball comes to the glass, and it says in the book here, it says the glass actually pushes against the ball too, but the ball is harder, and it pushes harder, and it's able to break through. That's really interesting to me. I've never thought about walls, glass, things that don't move in front of me, things that I can't really see moving. I've never really thought about them having force. Interesting. An object's weight can give an idea of the force needed to stop it. It takes a lot of force to stop a train. Only something, the caption here, only something with a huge amount of force could make this great big train stop. It takes a little force to stop a ping pong ball. A small paddle is enough to stop a tiny ping pong ball. That's very interesting, third graders. I don't know about you, but I don't think that this small ping pong paddle would be able to stop that large train, right? And this is something we kind of talked about before, just on a few pages ago, but how do you measure how much force you need to stop a massive train? Or like an airplane, for example. How much force do we need to stop those things? They're so big. It's really interesting to think about. Friction. Third graders, before I read this, if you have a wondering, if you have a question, if you have something you've learned, go ahead, pause the video, and write that down. And when you have done that, unpause the video, and we will read this next chapter with a heading called Friction. Okay, third graders, hopefully you paused the video. Again, I don't know if you did or not. Trusting that you're doing this and trusting that you're demonstrating integrity and writing down those wonderings, writing down those questions, writing down that new learning. Okay. Third graders, the heading here is friction. So again, what is this going to be about? What are the next few pages going to be about? It's going to be about friction. You might be thinking to yourself, what is friction? Well, hopefully these next few pages can answer that question for you. Friction is a force that slows things down or makes them stop. Rubbing your feet on the ground creates friction. The friction makes a swing stop. And down here, I know it's blocking it a little bit, but we can still see it. It says friction is created when an object, such as your feet, rubs against another object, such as the ground. So it sounds like friction is obviously something that slows us down somehow. So I'm thinking your feet on the ground, it's kind of like you're braking, like brakes. And I'm thinking maybe car brakes as well. I wonder if car brakes work with friction. I wonder if that's how they stop cars. I wonder if that's how they stop trains. We just talked about that. Friction from brakes makes your bike stop. So it looks like it makes your bike stop. Let me read the caption here. When you hit the brakes on your bike, the brakes rub against the wheels. So those little brake pads, I think, on our bike, which are right around here and in the back, usually around there, those push on the wheels, and that creates friction and slows it down. Perhaps that's the train. Perhaps that's a car. Same sort of idea. I don't know. A smooth surface makes less friction. You can slide easily on ice, but not on grass. I'm sure many of you have noticed that, third graders. If you've been on ice, it's very, very easy to lose your balance, and it's also quite easy to slide on it. So I hope you had fun with that. Changing shape. So we have a new heading here, changing shape. Forces change the shape of things. It takes a push to flatten dough. It takes a pull to stretch it out. The force of the wind bends the trees, twisting a balloon, changing its shape. Caption here with the arrow pointed right here. Someone made this balloon animal by pulling on and twisting a balloon. Wow, that's just one balloon? That's what that caption makes it sound like. Forces are everywhere. They help us eat, work, and play. Nothing would happen without forces. Third graders, that is the end of the book. I hope you have enjoyed it. Third graders, there is this great activity here. I'm not going to read it. I'm not going to go into it. But if you do have you have access to Epic, you can find this book on Epic. And if you want to do this ball toss game as an activity, go for it. I think it's a great way to think about force and to think about different things, to think about the different amounts of force that you need to play this game. Okay. Third graders, as I'm reading, I knew that was a nonfiction text, because I kept getting a lot of information. There were no characters in there. There was not a setting. There was not a problem and a solution. And at the end of the book, it only reinforces that for me. I have a glossary here. We know, third graders, that a glossary helps us understand some really important words. For example, magnetism. So we have magnetism in bold print here. And that is a force that attracts certain metals to magnets. We have force. Well, what is a force? Well, a force is a push or a pull. So the glossary helps us with some of those words that might be a little tricky, words like motion, okay, to understand. The glossary helps us do that. We also have this interesting text feature, which is further reading. Take a look at these different resources, books, websites we can go to learn more about forces. It's great that the authors include those sort of things if you're interested in forces. Finally, on the last page here, we have an index. We know, third graders, that the index, if I want to know, it's a big book and I want to know about gravity, for example. Well, guess what? Gravity is right here. And I can directly turn to page 7. So I don't need to flip through the whole entire book to find gravity. I can just go right to page 7. And that's where they're going to talk about gravity, because that's in the index. All right. So third graders, I hope you enjoyed this read aloud of this nonfiction text, A Push or a Pull, a book about forces. What I would like you to do is I would like you, using the notes function on Seesaw, I would like you to add 2 things that you have learned, and 1 thing that you wonder. So using the notes section on Seesaw, okay, please post 2 things that you have learned from reading this book, and please post 1 thing that you wonder from reading this book, okay? And you're going to post that into Seesaw on the notes section. If you need to reread the book, fantastic. Go on Epic, have a reread, think about what you've learned, and go ahead and post that to us on Seesaw. All right, third graders, I hope you enjoyed this. Have yourselves a great day today, and I will see you soon. Bye for now.